Recall the assumptions of the kinetic molecular theory, KMT, for an ideal gas. Under ideal conditions, gas particles are assumed to have negligible particulate volume and experience zero intermolecular attractive or repulsive forces. Identify how real gases deviate from ideal behavior. In real gases, molecules do experience intermolecular attractions. These attractive forces become increasingly significant when molecules are closer together, such as in a high-density, low-temperature, or high-pressure state. Analyze the microscopic impact of intermolecular attractions. When gas molecules are attracted to one another, they pull on neighboring molecules. As a gas molecule travels toward a container wall, the cohesive, attractive forces from surrounding molecules in the bulk gas pull it backward. Relate molecular collisions to macroscopic pressure. Because of these mutual attractive forces, the molecules strike the container walls less frequently and with less force than they would if they had no attractions among themselves. Because gas pressure is a macroscopic measurement of the force exerted per unit area by these wall collisions, the observed pressure of the real gas is lower than predicted by the ideal gas law. Conclude. The observation of a lower than expected pressure is best explained by the molecules being attracted to each other, which reduces the force of their collisions with the walls. This corresponds to option C. The correct answer is option C, are attracted to each other and do not exert as much force on the container walls as they would if they had no mutual attractions.